Alright, in this question you have to find the center of the power series. Okay, center. You can write C equals, look guys, this is x to the power n. So you could think of it as x minus c to the power n. So c is 0. Right? And what about the center for this one? X minus 2 to the power n. So center is 2. Find the radius of convergence of the power series. In other words, find r. Alright guys, let's determine the center first. What's the center? X minus c to the power n, so center is 0. Okay, to find the radius of convergence, start with the ratio test. Limit as n goes to infinity of an plus 1, negative 1 to the power n plus 1, x to the power n plus 1. If you replace n by n plus 1, you get n plus 2. Divided by an. So flip an and multiply by it. Okay, so we are trying to find the limit of the ratio. That's going to be limit as n goes to infinity of. We have an extra negative 1 in the numerator, an extra x in the numerator, right? Because here the power is n plus 1, here the power is n. You have 1 extra x in the numerator, and then the fraction n plus 1 over n plus 2. Alright, now let's talk about the limit. So, limit of negative x inside the absolute value sign is going to be limit of negative x inside the absolute value sign is same as absolute value of x, because that does not depend on n. Limit of that fraction is 1. So the limit of the ratio is absolute value of x. So guys, what we have just found is the limit of the ratio. Now we know that the series converges by the ratio test if the limit of the ratio is less than 1. That means your x is between negative 1 and 1. Guys, that's not necessarily the interval of convergence, because we don't know what's happening at the endpoints. So let's not worry about the interval of convergence now, because you are only asked to find the radius of convergence. So to find radius, guys, mark the center. Center is 0. Mark these endpoints negative 1 and 1 and find that distance. That distance is the radius. So that distance is 1, and that's all you are asked to find in this question. Alright, now go ahead and find the radius of convergence for the next problem. Start off by finding center. Now there's no x minus c to the n, so center is 0. Now to find the radius of convergence, do the ratio test. Limit as n goes to infinity of an plus 1, 4x to the power n plus 1 over n plus 1 squared, divided by an, right? Flip it, n squared over 4x to the power n. Alright, so now what are we going to have? Limit as n goes to infinity of, where do we have an extra x in the numerator? We'll put 4x there, and then the fraction, of course, n squared over n plus 1 squared, right? Now look, the limit of 4x inside the absolute value signs as n goes to infinity does not change, so it is absolute value of 4x. And what about the limit of that? This is the highest power is 2 here, the highest power is 2. If you expanded this, you will get n squared, right? N squared plus 2n plus 1. So both top and the bottom have the same powers, so as n goes to infinity, that limit is going to go to 1, right? So overall, the limit is absolute value of 4x. That's the limit of the ratio. Now, by the ratio test, we know that the series converges when absolute value of 4x, in other words, when the limit of the ratio is less than 1. So 4x is between negative 1 and 1. That makes x between negative 1/4 and 1/4. Remember, all you are asked to do in this question is find the radius, right? So let's mark the center. Center is 0, and then mark these two endpoints, negative 1/4 and 1/4. Okay, let me draw it a bit better. Okay, center is 0, and the negative 1/4 and 1/4. What is that distance? that distance is the radius, distance from the center, and that is going to be 1/4. Radius is always a positive number, okay? Because radius measures distance, right? Alright guys, what's the center for this? X minus c to the n, there's no c, so center is 0. You're asked to find the radius of convergence for this. I'm going to write limit as n goes to infinity of an plus 1. Replace n by n plus 1. Replace n by n plus 1. Okay, and then flip and multiply 2n factorial over x to the power 2n. Okay, so what is that going to be? A limit as n goes to infinity of, this is x to the power 2n plus 2 over 2n plus 2 parenthesized and factorial, and here 2n factorial over x to the power 2n. Alright guys, be careful when you deal with factorials, okay? Remember the trick with factorials? You must rewrite the larger factorial using the smaller factorial. Now before we get there, first of all, let's figure out how many extra x's we have. Here 2n plus 2 is the power, here 2n is the power, so we have x squared in the numerator. Of these two factorials, 2n factorial is the smaller one, so let's put it there. Look at 2n plus 2 factorial. So rewrite the larger factorial using the smaller factorial. Smaller factorial is 2n factorial. After that, guys, we need 2n plus 1 times 2n plus 2. When these three are combined together, you will get 2n plus 2 factorial. So cancel this. Now look, when n goes to infinity, right, the denominator is going to go to infinity. So overall, it's going to go to 0. So the limit of the ratio is less than 1. No matter what x is. Now, of course, when x is 0, guys, when x is 0, we know that at the center, every power series converges, right? So no matter what x is, the limit is less than 1. So guys, what I'm going to say is, no matter what x is, the series converges. Okay, because the limit here is less than 1. So if the series converges for all values of x, then the radius is going to be infinity. Okay, if the series converges for all values of x, then the radius is going to go to infinity. Wonder why? Okay, here is the center. The series converges for all values, positive, negative, whatever. So the radius is infinity. The distance from 0 to infinity is infinity. Alright guys, the next question is going to be a bit more work, because here you're not just finding the center or the radius, you are finding the interval of convergence. Alright, so start off by finding the center, x minus c to the n, c is 0. Now, then you will do the ratio test, okay? So let's do limit as n goes to infinity of an plus 1, that's x to the n plus 1 over 4 to the n plus 1, divided by an, flip it and multiply. So this is going to be limit as n goes to infinity of, you have an extra x in the numerator, extra 4 in the denominator. Okay, that is the limit of the ratio. We know by the ratio test the series converges when the limit of the ratio is less than 1. Okay, so I want to write series converges when the limit of the ratio, in other words, when you simplify, it is absolute value of x over 4, right? Because it doesn't depend on n, right? So the series converges when the limit of the ratio when absolute value of x over 4 is less than 1. What does that mean, guys? That means x over 4 is between negative 1 and 1. Multiply everywhere by 4, x is between negative 4 and 4. So series definitely converges for x between negative 4 and 4. Now, what about the endpoints? Alright guys, now look. When x is negative 4, does the ratio test tell us anything about the series? Let's go and have a look. When x is negative 4, the limit of the ratio is absolute value of negative 4 over 4. In other words, absolute value of negative 1, which is 1. The limit of the ratio is 1, And we know by the ratio test, if the limit of the ratio is exactly 1, the test is inconclusive. So we don't know what's happening at x equals -4. Likewise, guys, we don't know what's happening at x equals 4 either, because when x is 4, the limit of the ratio is 4/4, 1, absolute value is 1, ratio test is inconclusive. So we have to do 2 different tests to figure out what's happening at the endpoints. So I'm going to write when x is -4. Guys, go to the series in question and replace x by -4. Okay, when x is -4, you get sigma -1 to the power n. What is this? This is a geometric series. So guys, when x is -4, the power series turns into a geometric series with r equals -1, absolute value of r is 1. And what do we know about a geometric series whose absolute value of common ratio is 1? It diverges. Now check the other endpoint. When x is 4, go to the power series and replace x by 4. So x/4 becomes 4/4 to the n, which is same as 1 to the power n. That too is a geometric series, isn't it, guys? Because you're multiplying by 1 each time to get the next term. Geometric series with r equal to 1, absolute value of r is 1. That means the power series diverges when x is 4. So guys, finally, what is the interval of convergence? Interval of convergence is going to be -4, 4. We know by the ratio test it converges for all values of x between -4 and 4. When we check the endpoints, the power series diverged at each of these endpoints. So it's parentheses and parentheses. That is the interval of convergence. Now, what happens when x is bigger than 4 or when x is less than -4? So guys, go back to the limit of the ratio. When x is bigger than 4, the absolute value will turn out to be bigger than 1. The series diverges by the ratio test. Likewise, when x is less than -4, the limit of the ratio would be bigger than 1. The series diverges. So you don't have to check for values of x bigger than 4 or less than -4. Alright, have a look at the next question. Determine the interval of convergence for this power series. Okay guys, what's the center here? X minus c to the n. There's no c, so center is 0. So start off with the ratio test. Limit as n goes to infinity of an plus 1, right? Replace n by n plus 1, and this is n plus 1 factorial. Flip it, n factorial over x to the power 5n. Now be very careful when you simplify this, okay? Limit as n goes to infinity of x to the power 5n plus 5 over n plus 1 factorial, and then we have n factorial over x to the power 5n. Okay, this is going to be limit as n goes to infinity of, we have more x's in the numerator, so x to the power 5 in the numerator. Now n factorial is the smaller of the two factorials. N plus 1 factorial rewritten is n factorial times n plus 1. Okay, now when you simplify, what are you going to get for that? You're going to get limit when n goes to infinity, so n factorials cancel. You have x5 over n plus 1. Okay guys, now if you want to take x out, that's okay, but be careful. If x is positive, x to the power 5 is positive, but if x is negative, x to the power 5 is negative, so you can't remove x out of the absolute value signs. Okay, so this is going to be limit as n goes to infinity of 1 over n plus 1. Now n in this question is positive, so absolute value signs are redundant. So guys, when you take the limit, 1 over n plus 1 will go to 0. 0 times that is 0. So the limit of the ratio is 0, which is less than 1. So I will say no matter what x is, no matter what x is, the series converges. And remember guys, in this question you are asked to write the interval of convergence. So you would write from negative infinity to infinity. Now when you write infinities, you must put parentheses on either side. infinity and negative infinity are numbers that do not exist. Alright. Next question. Find the interval of convergence for this power series. What is the center, guys? X minus c to the n. There is no c, so center is 0. So here we'll have start off with the ratio test, limit as n goes to infinity of a n plus 1. So go ahead and replace all the n's by n plus 1 very carefully. 2 times n plus 1. Okay, parenthesize that and factorial it. And then here we have x to the n plus 1 over 3 to the n plus 1. That's a n plus 1. Divide that by a n. So flip and multiply. 3 to the n over x to the n. And then when that is flipped, 1 over 2n, parentheses, and then factorial there, right? Okay. Limit as n goes to infinity. This is going to be 2n plus 2. Put parentheses before you factorial that. Now look, we have an extra x in the numerator, an extra 3 in the denominator, and then we have 1 over 2n factorial. Alright? Now, we have to evaluate this limit, right? Remember the trick I've been telling you? When you have 2 factorials, rewrite the larger one using the smaller one. The smaller of these 2 factorials is 2n factorial, so rewrite that. Definitely use 2n factorial, and after that you need 2n plus 1 times 2n plus 2. Alright? And then copy down the rest. X over 3 times what? 1 over parentheses 2n factorial. Now cancel the 2n factorial with that 2n factorial. Now guys, how do you simplify this? Any idea how to simplify this? What you have to do is find the limit as n goes to infinity, right? Find the limit as n goes to infinity. Now, so the question is, how do you find the limit? Okay, the 2n factorials cancel, like we talked about. Now, if you want, guys, you can bring x over 3 with the absolute values outside, right? Outside the limit. Why can we do that? Because the limit depends on n, not on x. So if you want, you can put absolute value of x over 3, and then you are left with finding the limit as n goes to infinity of 2n plus 1 times 2n plus 2. So what is the limit? As n goes to infinity, this goes to infinity, right? Which is bigger than 1. Alright, so what does the ratio test tell you? The ratio test tells you the series diverges if the limit of the ratio is bigger than 1 or is equal to infinity, right? Okay guys, in this case the series diverges. Then you might say, what about when x is 0? Right? Because 0 times infinity is not necessarily infinity, and you might say, what about when x is 0? When x is 0, guys, in other words, when the center is 0, we know that the series converges. Why? Every power series converges at its center. When x is 0, the series converges because x equals 0 is the center. So what I'm going to say is the series diverges for all x except at its center x equals 0. The series diverges for all x except at its center x equals 0. Guys, I want you to remember, recall, every power series converges at its center. Okay, I showed it to you at the very beginning of the section. Every power series converges at its center, and because x equals 0 is the center, it definitely converges there. And the ratio test tells us that it diverges for every single other value of x, okay? So there's only one point or one x value at which the power series converges. Now, how do you express a single point as an interval? Okay, guys, for the interval of convergence, to show that it converges only at x equals 0, the interval should look like parentheses 0, comma 0 parentheses. That tells you between 0 and 0 there is 0, right? And that's the only value in that interval at which the power series converges. Alright? Alright guys, find the interval of convergence for this power series. Alright, so first let's say where the center is, okay? Center is at c equals 4, right? 4 minus 4. Okay. So now, do the ratio test, limit as n goes to infinity of. Now look, we are going to replace n by n plus 1. So what is the new power? When n is replaced by n plus 1, that becomes n plus 2. X minus 4 to the power n plus 1. Then n plus 1 times 9 to the power n plus 1. That's an plus 1 divided by an. Flip and multiply n times 9 to the n over negative 1 to the power n plus 1 x minus 4 to the power n. Okay, so let's simplify limit as n goes to infinity of. We have an extra negative 1 in the numerator, an extra x minus 4 in the numerator. Here the power on 9 is n, the power on 9 is n plus 1, so we have an extra 9 in the denominator. And look at the fraction, we have n here and we have n plus 1 here. Okay, now let's go ahead and compute this limit. This is going to be limit as n goes to infinity of now negative 1/9. Negative 1/9 when absolute value is 1/9, guys, and absolute value of x minus 4 is x minus 4. They can both come out of the limit, the 1/9 and the 1/9 and the absolute value of x minus 4. They can both come out because they do not have n in them. The limit only depends on n. Okay, so what is this limit going to be? This limit is 1, so we have 1/9 times x minus 4 times 1. So we now know the limit of the ratio is 1/9 times x minus 4. That is the limit of the ratio. But what does the ratio test tell you? Okay, series converges when the limit of the ratio is less than 1. That means absolute value of x minus 4 is less than 9. Right, multiply both sides by 9. X minus 4 is between negative 9 and 9. Now we add 4 everywhere, that will be 13, and this will be negative 5. So guys, what this tells you is the series converges for all values of x between negative 5 and 13. What about negative 5? Now, negative 5, when you plug in here, that's negative 9. Absolute value that 9 over 9 is 1. The ratio test is inconclusive. Similarly, when x is 13, that will be 9 over 9, which is 1. The ratio test is inconclusive. So guys, at each of these endpoints, you must do a different test to figure out whether the series converges at x equals negative 5 and at x equals 13. Okay, let's check one by one. When x is negative 5, go to the original series. Okay, the original power series in question. Replace x by negative 5. So in place of x, I put negative 5. Remember, in the original power series, we had x minus 4 to the n, negative 5 minus 4 to the n. Denominator n times 9 to the n. This is going to be sigma n equals 1 to infinity, negative 1 to the power n plus 1. What's this going to be? This is negative 9 to the n, and this is n times 9 to the n. Okay, now let's do a bit of algebra to make this work. This is negative 1 to the n plus 1. Hey guys, I'm going to rewrite this as negative 1 to the n times 9 to the n. There's nothing wrong with that, right? Because you can multiply the bases and keep the exponent the same. And the denominator is n times 9 to the n. 9 to the n's cancel out. And then if you continue to simplify, you will see that you are multiplying with like bases. Put the base down, add the powers, n plus 1 plus n, that's 2n plus 1 over n. Now, what do we know about 2n plus 1? Guys, n is a positive number, 2 times n is a positive whole number, 2 times n is an even number. When you add 1 to an even number, that will be always odd. Okay, now tell me what is negative 1 to the power of an odd number. Negative 1 to an odd number is always negative 1, isn't it, guys? It will never be positive 1. Now what we can do is, this is negative 1 times 1 over n. I can pull the negative out. Why? The constant from a constant multiple can be pulled out of the summation sign. So guys, now you have a very familiar series in front of you. Isn't that a p-series, guys, whose p-value is 1, and therefore that diverges. So guys, if that one diverges, the negative of that also diverges. It's given. You don't have to do anything special to show that. Okay, this is a p-series, also known as the harmonic series. Harmonic series has p-value equal to 1, so it diverges. Negative of that also diverges. So guys, at the left-hand endpoint, when x is negative 5, the series diverges. Let's check the right-hand endpoint, okay? When x is 13. Once again, guys, go to the series, negative 1 to the n plus 1. Now you have x minus 4, so you got 13 minus 4 to the power n over n times 9 to the n. Okay, replace x by 13. And then simplify this. Negative 1 to the power n plus 1, 13 minus 4, 9 to the n, n times 9 to the n. 9 to the n's cancel. So when x is 13, guys, your power series turns into an, what is this series called? It turns into an alternating series. So I'll make a note. It is an alternating series. So when x is 13, your power series turns into an alternating series. So do the alternating series test to determine the convergence or divergence of that. Alright guys, because this power series is an alternating series, I'm going to say do alternating series test. Remember the two conditions? First of all, for an alternating series given here, what is an? An is the part without the alternating component, right? Alright, what are the two conditions, guys? Limit as n goes to infinity of an must be computed, and then that limit must be 0 for all n. Now the next condition for an alternating series is are the terms decreasing for all n. Now an is 1 over n. What is an plus 1? 1 over n plus 1 is indeed less than 1 over n for all n. So guys, the alternating series passes both conditions. That means the alternating series is convergent, right? So we can say the power series converges when x is 13. Power series converges by the alternating series test when x is 13. 13 is the right-hand endpoint. So guys, now to answer the interval of convergence, for what values of x does the original power series converge? Okay, first we got the interval negative 5, 13 using the ratio test. Now here we know that the power series converges when x is 13, put bracket around it. And at negative 5, we could show that the power series turns into a harmonic series and it diverges at negative 5. So that is strictly parentheses. So it's called a half open, half closed interval.